Bell work from yesterday. How in the world? Like I said, we've gone over this. We went over it last week. I'm going over it again. We do the same thing. Nothing changes. We do the same thing we did last week. This is BF is the midsegment of ADG. Well, folks, if the midsegment is 26, first of all, this picture is not sitting the right way for me personally. How do I like for this picture to be? I want it to be vertical, okay? Now, if 26 is the midpoint, then what is the base of that triangle going to be? What's this right here? It's AG, which is going to be, how'd you get 52? 26 times 2 is 52. So you're saying that this segment, AG, because BF is the midsegment of the whole triangle, if it's 26, then the base is going to be 52. Do you guys agree with that? Yeah. Okay. Not only is AG, and I don't even know what it's saying, okay? I'm not even worried about this. But not only do I know about AG, is AG equal to itself? What property says that something is congruent to itself or something is equal? The reflexive property says that something is equal to itself. You're supposed to know that, okay? What do we know is, what's one expression that is AG? X minus A. What else do we know about AG? It equals 52. Do I have enough information to solve for X? Yeah, I do now. Add 8 to both sides and you get X is equal to 60, correct? All right, now, what else does it say? We found X. Well, that's all well and good, but that's not really what I don't care about finding it. We got to find the length of AB, BD, BC, CD, AD. Holy moly, that's a whole bunch. Now, it says that CE, and I'm looking at the second portion right here. CE is the midsegment of triangle BDF. So if 26 is the base of that triangle, then what is the length of CE? Huh. Okay. That might be helpful to us. What else are we going to have to do? Take 26, divide it by 2, you get 13. Okay? What else do we have to do? AB is 5x minus 23. We'd already solved for 60, so you're saying take 60, substitute it for x. 5 times 60 is 300? Wow. Totally 277 millimeters. These numbers don't make any difference. They don't make sense, but who made it up? I did. That's why they don't make any sense, okay? Did I do the problem correctly, though? Yes, I did the problem correctly, so I know that I'm on the right track. So if AB, if this piece right here is 277, BF is the midpoint, then what is BD have to be? 277. How in the world am I going to figure out BC and CD? I'm going to take 277 and divide it by 2, and that's going to give me 138.25. And that's going to be the length of what? BC and CD. So now we've got these two are congruent because CE is the midsegment of that little triangle. So did y'all say it was 138.25? 0.5, okay. I didn't think that was right. So that means that this is 138.5. This is 138.5. AB, I found it. BD, found it. BC, yes. CD, yes. Oh, what's AD? I got AB, that's done. I got BD, that's done. I got BC, yes. CD, yes. How do I find AD? Multiply what by 2? 277. Did y'all get 554? That's that whole segment AD. Y'all, these numbers are off the charts, okay? I tried to make them. At least we didn't get a decimal. I didn't want to get a decimal. If I could keep from it, I still got one, though. Okay? Does that make sense now? Now, you know what you're going to have next week for mail work? Same type problem. I will not help you on it. No, absolutely not. No way. You got to know that. You got to. Okay? You should have gotten this. 7, 10, and 11. In order for two polygons to be similar to each other, then their angles have to be what? The same. They have to be congruent. And the sides have to be what? Very good, Brandon. Very good. The angles have to be congruent and the sides have to be proportional. Folks, you got to know that. Every time I ask you, you should be able to tell me that, just like that, okay? If two polygons are similar, then their corresponding angles have to be what? Congruent, and their corresponding sides have to be proportional. Now, look at number 7. It said to identify the pairs of congruent angles and corresponding sides. For number 7, you should have had angle J, and I would just start checking them off when you find them. Angle J is congruent to what angle? S. Angle K is congruent to? Angle L is congruent to? Very good. M is congruent to? V. Excellent. All right, and then you should have JK corresponds to ST. That's fine. Which is equal to KL, which corresponds to TU or UT. No, just check them off. No, no, it's all equal, so it doesn't matter. All right. LM corresponds to UV. MJ corresponds to SV. And when you check those sides, the similarity ratio, okay, choose any side, any set of sides. Which set of sides do you want to choose? ML to who? UV. What is the length of ML, folks? 30. What's the length of UV? What's the similarity ratio, y'all? How much? 5/6, isn't it? The similarity ratio will be 5/6, okay? That's what you should have gotten once you checked all of those ratios. How many of you got number 7 correct? Hands up. Very good. What part did you not get correct?
Yeah, I would have to do that.
I did JK over SQ equals ML over VU, and then I got 20 over 24 equals 30 over 8, and I'm
Okay. Didn't even ask you to do that. But you know how to set it up, in case you did. Read the directions. When all else fails, read the directions. Look at number 10. It says, determine whether the polygons are similar. If so, write the similarity ratio and the similarity statement. Folks, what do you have to know about corresponding angles? They have to be congruent. Thank you very much. And the corresponding sides have to be proportional. Thank you. Number 10, are they similar? No, they're not. How come? They don't match. How did you set up your first one, Amber? Your guide was big over little. I like that. Hey, let me ask you something. Could I have used little over big? Yeah, as long as I keep all my numbers in the right line. So then, what did you use? 24 over 18 should be equal to what over what? It is 4/3. What's the other set of sides? 54 and 36. And when you reduce those, what do you get? 3 over 2. If my ratios don't match, then that's match. Good point. if I would have used little over big for my guide, still ain't going to work out. Because you will end up with 3 over 4 is equal to 2 over 3. Well, folks, how much would you rather have? 3/4 of $1 million or 2/3 of $1 million? Why?
Ain't that more?
Yeah, that's right. Yeah, it's more. Which would you rather have? We all want 3/4 of $1 million. I'll take 3/4 of $100. Bring it on, okay? But I want the most, right? Questions at all? It says the ratio of the model car's dimensions to the actual car, that's our guide, is 1 to 56. Okay? Now, it says the model has a length of 3 inches. Where am I going to put 3 inches? Why? Because it's a model. Absolutely. And then we have to find out the actual length, don't we? What's the length of the actual car? Okay. Oh, hold up. Wait a minute. 3 inches. This said 3 inches, didn't it? Okay. Here we go. Cross multiply. You get x is equal to 56 times 3, which is what? 168. I'm just asking. Let's think about this. Are you going to give me the measurement of my car in terms of inches? No. I mean, seriously? No. How many feet would that be? How would I even begin to figure it out? Divide by 12. So divide it by 12, and what do you get? 14 straight up 14? Straight up 14. I don't know if that's a long car or not. It's probably 14 feet. Did you get 168 to start with? All right, then you got the right answer. You just didn't convert it. That would be like, I don't want anybody referring to my height as inches. I want to hear. I mean, especially, because I'm a tall woman. I'm not extremely tall, but if I were, this is all recorded. Nobody cares about this. Don't listen. Here we go. Excuse me. Oh, we don't even have our notes out. That makes me happy. Good girl. Fast. Speedy. Call you Speedy. Here we go. Now, find the length of the model to the nearest tenth of a centimeter. I ain't helping you on this because I'm hateful. What do we do? Oh, meters and centimeters. What are we doing? We're going to stop. Wait a minute. You're going to go back and you're going to read the problem. That's what you're going to do. You're going to find the length of the model to the nearest tenth of a centimeter. Folks, I know we've got 2 different measures because we're talking about a model and the actual car itself. So we're supposed to have different units of measure. You've got to find x. I want you to do that now. You don't need me to prompt you through this problem. Figure out x. Figure out what x is. Remember in similarity that corresponding sides are what? Corresponding sides are proportional. So you need to set up corresponding sides over each other, and then you ought to be good to go. Solve for x. It's always back there. If you're absent, always check the makeup work drawer, okay? Corresponding sides are what we put over top of each other in our ratios, okay? If I would not, you still might get the same answer, but I cannot guarantee that that's always going to be the case, okay? Put corresponding sides over each other, and that's what she did. 5 over x is equal to 1.8 over 6.3. And watch this. If you are a kinesthetic learner, what's that mean? What's kinesthetic mean? No. It means you got to do. How many of you love hands-on stuff? You'd a whole lot rather be hands-on stuff. Okay. If you're a hands-on person, if you like building and puzzles and you like doing, then watch this. 5 over x better be equal to, I have to do the same movement. 1.8 over 6.3. If you will think on these problems, you will see me a lot of the times go with my hand, 5 over x is equal to 1.8 over 6.3. If you'll get into that habit, it's kind of like an echo. What you do the first time we want to see it again, okay? Or a repetition, rather, not an echo, because that's sound. What is 1.8x? What's 5 times 6.3? 31.5. When I divide by 1.8, Cody, you still might have the right answer. What's that? 17.5. 17.5 watts. Why is it centimeters? It's centimeters because we're solving for the model, okay? And it has to be centimeters. How many of you got 17.5? It is to the 10th.
So 18 is wrong.
17.5 is correct because this says nearest 10th, folks. Where's the Where's the 10th place? One place past. Yeah, it'd be wrong because you weren't following the directions. Okay, I probably would have counted off partial credit. Yes, sir. Yeah, that's cool. You don't have to, but it's good for you to check that. Let's look at the next one. It says a boxcar has the dimensions below. What's a boxcar? A boxcar. Isn't that on a train, y'all? That's a train car.
Well, they also got the little kind you make with the Boy Scouts. Yeah, Boy Scouts is racing.
That's a derby car, ain't it?
This little boxcar here. We talking about the car like this.
We talking about a car like this, y'all. That one right there. That is humorous to me. We talking about the car like this. That's a no. Yes, no. But what y'all race in Scouts? That's a derby car. Soapbox derby. That's what they call it, isn't it? What? I don't know what to call it. I ain't a scout, and I don't know. Here we go. But I'd think a box car is a train. It's one of the cars on a train. Here we go. Not that that's the important part of this particular example. This isn't train class. This is geometry class. Boxcar has dimensions. Model of the boxcar is 1.25 inches wide. Find the length of the model. How am I going to set this up? Model over, we can do that. Don't have to, but I can go that way. Model over boxcar. Watch what happens. If you set it up differently, don't erase anything. How did you set it up then? 1.25 over who? Good. Is equal to? All right, that'll work. All right, again, watch what, if you watch the movement, I'm going to have 1.25 over 9. Where do I have to start? On the right side, x over 36.25. Do you see that? When I cross multiply, I get 9x is equal to, whoo, big number. What's 1.25 times 36? Is that what you said? Divide both sides by 9. Right? Now, shh, listen. Look. Nearest inch. Oh, approximately 5 inches. How many? Wait until I turn around so I can see. How many of you got that right? High five, y'all. There we go. That's what I'm talking about. You got to be able to do this. Do you feel good about this? Now we're moving. We're moving. Questions at all? That when two figures are similar, the corresponding angles are going to be what? The corresponding angles are congruent, and the corresponding sides are going to be what? Proportional. Okay? You have to know that. Have to know that. Corresponding angles are congruent, corresponding sides are proportional. Now, just like we had all these theorems and postulates when we were going over triangle congruence, then we have the same type of theorems and postulates in similarity. Remember, you guys would always ask me, but isn't there some people wouldn't, maybe you wouldn't ask me, but you would put something like this. And I would go, how are they congruent? And you would go, angle, angle. No, wait, we didn't go over anything that said angle, angle. We went over side, 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 side angle, side angle, 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 side angle, side, hypotenuse leg. Side angle, I don't know what I just said. Side, side, side angle, side, angle, angle, side, angle, hypotenuse leg. There were 5 of them we went over, okay? This was never one of them, never. When it was just angle measures and that was it. But we can use angle-angle similarity, and look how they note that. Look at that right there. Angle-angle similarity. Yeah, you did. It's okay. All right, it's all right, me too. If 2 angles of one triangle are what? The corresponding angles have to be what, folks? In similar triangles, the corresponding angles have to be congruent. To 2 angles of another triangle, then the 2 angles are going to be similar. The 2 triangles are going to be similar to each other, okay? I want you to think about this. A 90-degree angle is a 90-degree angle, right? Let's look at this. Okay, and pretend that I don't have the shaky board. Do I still have 2 90-degree angles? Yeah. It doesn't matter if one of the little tiny angles are just little bitty tiny angle or some great big old 90-degree angle. A 90-degree angle is a 90-degree angle. What reason I say that is it doesn't matter the shape, the size of the figures. What matters is the measure of the angles, okay? If angle J is congruent to angle X and angle K is going to be congruent to, what's its corresponding angle? Y. Then those 2 triangles are going to be, according to this postulate, they're going to be similar to one another. So if I were to see this marked up, these 2 triangles marked up like this, then I would be able to write a similarity statement that says triangle JKL is similar to triangle XYZ. Why are they similar? They're similar because of angle-angle similarity. You should be writing this down. They're similar because of angle-angle similarity. And folks, you got to put that similar sign there. You have to. Why are they similar? Because angle J is congruent to angle X and angle K is congruent to angle Y. I have corresponding angle congruent, corresponding angle to congruent, which makes angle-angle similarity. That's our postulate, okay? Remember how we had to mark up our pictures and then we decided whether it was side, side, side or side, angle, side? This is kind of sort of what we're going to be doing here, okay? Now, side, side, side. Corresponding sides in similar polygons have to be what? Proportional. So this theorem says if corresponding sides of 2 triangles are proportional, then the triangles are what? Similar, right? No, it's not the same thing. It isn't. If the corresponding sides of two triangles are proportional, then the triangles are similar to one another. What's that going to look like? You may have numbers like this right here. Write this down, please. If I had, and I'm just choosing random numbers, okay? But if I had that this triangle ABC, the side measures were 3, 5, and 8. I'm just randomly choosing numbers here. No significance about them at all. And I would also have that these other triangles were, let's see, let's go 18, 15, 24. This is already given to you, okay? I have to determine whether these two triangles are similar or not, okay? Now, how am I going to do that? I got to check the ratios. And I've got to make sure that each of my similarity ratios, each of these fractions are going to be equal to the same number, okay? So if you're looking at these, look at these two triangles. Are they sitting the right way? They're sitting the same perspective, aren't they? So the way they're sitting right now, if I were to start over here with the little one, 5 over what? 5 corresponds to what in the other triangle? 15. Well, that reduces to 1/3. Do you guys agree with that? All right, 3 corresponds to what in the big triangle? 18. Oh, that's 1/6, isn't it? Hey, do my fractions match? No, they don't match. Do my triangles, are they going to be similar to each other? These two triangles are not going to be similar to each other. So triangle ABC is not similar to triangle GFH. Write that down.
Is that really the symbol?
That is really the symbol.
So,
Not similar to.
because most numbers not from the three,
It's because they don't share the same ratio. If all, you'll see here in just a second, because we're getting ready to do one, but guess what? It's going to be okay. All right, so let's look at it. It does without the equal sign, doesn't it? Okay. So look at this. Draw this out in the margin or in an empty space. There's my right triangles again. The congruence, well, we're dealing with similarity.
I mean, like, making it marking stuff.
Okay, well, this is kind of sort of the same, but not. Okay, we're going to deal with numbers here, okay? Let's say that I have, let's say those are my measures. And we've got to determine whether these two triangles are similar or not. So we only have 2 options for similarity. Right now, we only know angle-angle similarity and side-side-side similarity. Well, let's just talk about this. Do I know anything about these angles? I got 2 right angles. I have 1 angle in each triangle, correct? This, though, denotes that I've got to have 2 angles congruent in both triangles. Do I know anything about a second angle? No, I don't know anything. So guess which one I'm not going to be using? I will not use angle-angle. Mark it out. So we're going to try to see if these 2 triangles are similar based upon side-side-side similarity. Corresponding sides have to be what? Proportional. Corresponding sides have to be proportional. Corresponding angles have to be what? It's up here on the board, I'm just saying. Turn around. So if I wanted to check this, what are you going to check first? 3 corresponds to what? 6. What's 3/6?
1/3. Oh,
That's right, 1/2. Let's check the other one. That's all right. 5 corresponds to what? 10, which is 1/2. Do I have to keep the little number on top for this last ratio? Yeah, I do. Why? Because I've got to keep them in the same order. If I start with little over big, then I've got to stay little over big, little over big. Y'all cool with that? Okay. So what's the last ratio I have to check? 4/8, which is 1/2. Hey, all of my similarity ratios match. Are these two triangles similar? Yes, we got to write a similarity statement. That is absolutely correct. You have to make sure. Side, side, side similarity means that all 3 sides have to be what? Proportional. High five in the air. Thank you. All right. Triangle ABC is similar to what? YXZ. By what theorem? Side, side, side similarity. What if I forget and I don't put my similarity symbol at the end? It's probably going to have points counted off because I need to know that we are dealing in the land of similarity and not congruence. Pardon me? That's the answer. This is showing how we get to that answer. Okay? That's showing our work. Let's look at another one. Side angle side. Let me just refresh. Similar triangles, similar polygons. Angles have to be what? Congruent. Sides have to be proportional. Okay? You tell me what's going to go in these blanks then. If an angle of one triangle is blank congruent, to an angle of a second triangle, and the lengths of the sides that include these angles are proportional, then the triangles are going to be similar to one another. Side, angle, side. It might look like this. Side, angle, making up numbers here, okay? Making up numbers. Side, angle, side. Pardon? Okay. To answer your own question? Okay. How can I check? Are they marked? Yeah, they are. I could put 2 little tick marks. Are my corresponding angles congruent? Yes, they are. How do I know they're marked congruent? Okay, so I would write, my first way to prove is that angle Z is congruent to angle N. Okay. Do you see how this is side angle side? Kevin, do you see side angle side? You see it? Side angle side. You see that? Everybody see that? Yeah? Now what do I have to check? I have to check this stuff. All right, see if what's proportional, Dennis. All right, so give me a ratio. 5/15, which reduces to what? 1/3. Okay? We've got to start. What else do we have to check? We've got to check 8/24. What's that reduced to? 1/3. Are my sides proportional? Yes, they both match. What if one of my ratios happened to end up being 1/2? They would not be proportional. Therefore, my triangles would not be similar. Are my 2 triangles similar, yes or no? Yes, so give me a similarity statement. Kel, start my similarity statement. Triangle who? XYZ. Jade. is similar to what? Get them in the right order. Very good. And Chrissy, what theorem or postulate says that these two triangles are similar? Side angle, side similarity. We only have two to work from so far. We only have angle, angle similarity and side angle, side similarity. What do you think? Facile or difficile? Right now, they're facile. All right, let's move on. There they are. Gorgeous graphics. Beautiful. Let's look at the next one. Look at, oh, y'all love that bow tie picture, don't you? Yes, you do. Don't play like you don't. Hey, is there anything I can mark up automatically? Vertical angles, okay? You have the right to mark those up. Mark them up. You have the right to do that. I can tell you until I'm blue in the face. Mark up vertical angles. You can do that. Now, look at it. Explain why the triangles are similar and write a similarity statement. Well, what kind of information do I have given to me on the pictures? Oh, I have two congruent angles. Huh. And we only know two postulates and or theorems, angle, angle similarity, and, oh, we know three. Do we know three?
Yeah, we used to.
All right, my fault. My bad on that. So we have three options. Which option are we going to use? Do I know anything about them sides? No. Given to me in that picture, do I know any side information? No. Amber, what's your thoughts? Why? Because the only given information I have is about two of the given angles, isn't it? And I know that because, B/C because, angle A is congruent to angle who? Thank you. And angle BCA is congruent to angle ECD, which that gives me my two congruent angles. Then what can I conclude? Triangle ABC is similar to triangle who? DEC, good. Based upon which postulate or theorem? Do you guys agree with that? Not because he said it, but because you get it. How many of you see that and you're like, yeah, that's cool, I get that. Okay? For now, kinda, sorta. Pardon me? Angle, angle. Because look at the only information we were given were about angles. If that's all the information, if I'm not given any side information, then I cannot choose these. I don't know any side information. Okay? Let's look. Let me just see what's next. Hey, I tell you what. Let me look. Here's what I want you to do for homework, and I want you to start on it right now. I want you to complete these notes. Okay? Now hold up. Yeah. That's it. Can we do that? Yeah. All right, so let's think about what we have. We've got no 7 and 8. No 7 and 8. We're going to go over them tomorrow. Okay, but I want you to do something right now. Okay? So I want you to do 2, 3, 4, and 5. Nope, don't want you to do 6. Okay, so I want you to finish. Examples what? Examples 2 through 5 for homework. And I want you to work on them right now before you leave this room. You don't need to ask me for help. Try each other first. You got notes. Try it. Okay? You've got to. Folks, I'm telling you what, when you get in there and on the SOL, you're on your own. I will be sitting in the corner doing my thing. And it won't be, I will be sending you positive vibes. But that's it. I will walk around and make sure nobody's cheating. Oh, you do this number right here. You look around, see what your buddy next door's got on his. No, they're not.